So you have received 2 sheets that are orange colored, and I like to call those my reference sheets. I actually give those more in, like I said, in grade 9 when we're introducing these concepts. But because you guys missed out on that experience due to lockdowns and stuff like that, I'm giving it to you now as well. This is more just for you guys to go through on your own and relearn the rules if you don't remember them. I'm going to go over them very briefly right now, and then just make sure you go home and go over them as well. Do you guys have the sheets? Yeah, okay. So here are the basics of exponents. We have a base and an exponent. The product rule is when you are multiplying two powers that have the same base, you can actually go ahead and add the exponents. The quotient rule is when you're dividing two powers that have the same base, you can subtract the exponents. The 0 rule is anything to the power of 0 becomes a 1. The 1 rule is there. Negative exponent, we're going to go over that in a little bit more detail when we do our questions, but anything to the power of a negative exponent has to be rewritten as a fraction with a numerator of 1 to get rid of that negative exponent. Power of a power is you just multiply the two powers together. Power of a product, you take the exponent on the outside and you can basically multiply it to all the terms inside the bracket. And then power of a quotient, the same idea, you take the exponent and you can apply it to both of the numbers inside of the bracket. At the back of one of your sheets, I've also given you an exponent table. So you're welcome to use this as in place of your calculator, because I don't know if you'll have a calculator this unit. Let's see if the unit needs it. But I'll never ask you crazy hard questions. This is just more for reference, so you don't need to always rely on a calculator. All right, so in today's lesson, like I said, it's a little disjointed because I feel like there's no flow. We're going to just do a bunch of different questions and go through the rules as we come upon them. For example, number 1, we have 5 to the power of 3 times 5 to the power of negative 4 divided by 5 to the power of 2. Now, we don't want to be sitting there and multiplying all these numbers, like 5 times 5 times 5 and 5 times, that would take too long. So we're going to go ahead and use our power laws that we've just learned, which is when you have the same base and the numbers are multiplied together, you can go ahead and add the exponents. 3 plus negative 4, if you need to write that down, you can just go on a rough sheet of paper and go 3 plus negative 4. That's going to give me negative 1. So this would be 5 to the power of negative 1 over 5 to the power of 2. Now, in the next step, again, you have the same base and a division sign, so we're going to subtract the exponents. That's going to be negative 1 minus positive 2. If you were to solve that, that gives you negative 1 minus 2, which is just negative 3. So really, these are exponent rules that you have to be mindful of, but make sure you just have a rough sheet of paper to do the work so you know where you're getting the numbers from. But negative 1 minus 2 is negative 3. When you have a negative exponent, to get rid of it, you make a fraction with a numerator of 1, and then you rewrite the entire question without the negative sign. So it's 1 over 5 to the power of 3. Does that sound familiar from grade 9? Do you guys remember learning that? Negative exponents? Yeah. And then we can solve this by going 1 over, this is in your chart, so 5 times 5 times 5 is 125. Okay, question number 2. And like I said, we have so many examples. I'm just going to keep going. If you're confused about something, let me know and then I'll explain it again. But other than that, we'll just power through. In this question, I feel like I need to rearrange the question so that my 2's are together and my 3's are together. And you're allowed to move things around when it's a multiplication sign. So because of that multiplication sign, I can write it as 2 to the power of negative 2 over 2 to the power of negative 3 times 3 to the power of 0 over 3 to the power of 3. Do I need to do this step? No, not at all. But this just helps me visually see that I can use the power laws for each one of the fractions separately. Okay, again, you go to your rough sheet of paper, negative 2 minus negative 3. That's like saying negative 2 plus 3, which is just the number 1. So it's going to be 2 to the power of 1 times. You can do this in a number of different ways. You can use power laws, or you can say 3 to the power of 0 is a 1. So this is like saying 1 over 3 times 3 times 3 is 27. If you use power laws, that's totally fine as well. What you would have gotten if you did that is 3 to the power of -3, which is 1 over 3 to the power of 3, which is still 1 over 27. So either method would have given you 1 over 27. Okay, then you can't do anything further with this, so it's just going to be 2 over 27 as your final answer. To the power of 1? Yeah, sure. So see how I have these exponents. Oh, I don't know what I just did. See how I have these exponents over here? I'm subtracting them. So I'm going negative, I'll write it down again here, -2 minus -3. That's like saying -2 plus 3, which is the same as just +1. Yeah, we're good? Okay. Okay, so again, oh, I don't like when there's no flow, but we can't do anything about it. We're just gonna have to do it. Brackets matter for powers. If there is a negative sign outside of the bracket, it means this 0 does not apply to that negative sign. That 0 only applies to the base, which is inside of the bracket. So the reason why that's important is because regardless of what's happening with the power, that negative sign will always stay in the front and we'll have to deal with it afterwards. Now for this, we are going to use the rule of a power, and we're going to get 3 to the power of 0, because 3 times 0 is just 0. And anything to the power of 0 is equal to 1, so the final answer would be -1. Okay, and again, if you're confused about something, just stop me and I'll explain it again. For the next question, our base is -3 and our exponent is -2. So to get rid of the -2, we're going to make it into a fraction where it's going to be 1 over -3 to the power of 2. And that's just an easy solve. It's going to be 1 over 9. I don't know why it keeps deleting every single time I write it. Bea? For question B? Okay, so let's do the whole thing again. So what I'm going to do is I recognize that I have a negative exponent, and for me to get rid of that negative exponent, I have to make a fraction where it's 1 over, and then I copy the question again, except now instead of a -2, I'm going to keep it as a +2. So it's going to be -3 to the power of +2. And you always do this. No, you don't have to put the bracket. Well, you should, because you want the negative to be with the 3. So you should keep a bracket, yeah. And then -3 times -3 is just a 9. Rahiman? Oh, yeah, in the next line. Yes. For the next question, we have 5 times m to the power of -2 is 1 over m squared. And then this would just be 5 over m squared. By the way, like I said, there's no order to these. So some of these questions are so much easier as you get to like the bottom of the page. So don't think that they're going to get harder like they usually do. All right, on to the next couple of questions. Here we have questions D, E, and F. And I have to tell you guys a little bit of a trick. I feel like I told my last class this trick and it confused them, but some of them got it and it really helped. So this question can be solved in 2 ways, the long way and the short way. I'm going to show you the long way first. So to do the long way, you're going to go 1 over, and I'm going to change w to the power of -5 to 1 over w to the power of 5. Everyone see what I did there? I just changed this negative exponent to this. Okay, now to solve this, you take the reciprocal and you end up getting w to the power of 5, because 1 divided by 1 over something is 1 times the reciprocal of that. So that's the answer you would get. Yes. Like if I wanted to show more steps, I would write it as 1 times w over 5 over 1, and then that gives me w to the power of 5. Now that's the long way. The short way is, and I'm going to repeat this a couple of times, when you have a fraction and everything is multiplied together and you have a negative exponent, to get rid of the negative exponent, just move it to the other position. So if you have a negative exponent in the denominator, to make it positive, you just move it to the numerator and you can change the sign of the negative exponent to become a positive exponent. If you have something in the numerator that's a negative exponent, you can move it to the denominator and change the sign. And I'm going to do this a couple of times in other questions, and hopefully it'll start to make sense. So the shortcut of this would be, I have a w to the power of -5 in the denominator. I'm going to move it to the numerator and I'm going to make it into a positive. So the answer would just be w over 5 to the power of 1, which is the same as just w to the power of 5. If you don't like that shortcut, you don't have to use it. You can always use the long way. It's totally fine. But I find that this helps to do the question a little bit faster. Then you would just multiply it to it. Yeah, actually, we're going to get to an example and I'll show you. I know exactly what you're talking about. So I'll show you what I mean by that. Sarah? The next part is what we have been talking about. So a -1 is an exponent. We're going to change it to 1 over 2x to the power of 1. And anything to the power of 1 is just the same thing. So it's 1 over 2x. That's it. And then for question F, we're going to use power laws again. So this is very much like examples 1 and 2. So first I'm going to use a power of a power for this part right here. 3 times -1 is going to be -3 times 3 to the power of -2 all over 3 to the power of 4. So you can go ahead and use power laws and see what you get for this one. Now, when you get an exponent this large, I don't expect you to, it's not in our chart, so I don't expect you to solve it. You can leave it as just 1 over 3 to the power of 9. But the one thing I don't want you to do is have any negative exponents in your final answer. Having a negative exponent in your final answer is really poor form. So if you left it as 3 to the power of -9, it's not complete. You have to change it such that the negative exponent is gone. All right, so you guys, let's just take up questions G, H, and I. For question G, 7 to the power of 0 became a 1, and then I got a fraction of 1 over 4. Found a common denominator, I got 3 over 4. Did you guys get that as well? Yeah? Okay, for question H, remember BEDMAS. BEDMAS tells me I have to solve what's inside the bracket before I can do the exponent. So I first solved what was inside the bracket. I got 4 over 3 to the power of -1. Here is another trick that you can use. It's a shortcut. If you have a fraction to the power of -1, what you can do is you can take the reciprocal of the fraction and then you can change the negative exponent to become a positive exponent. So I'll give you another example of that over here. If I had, for example, 2 to the power of 3 to the power of -5, we're not going to solve this. You can make this into a positive exponent by taking the reciprocal and making it into just to the power of +5. Okay, so a little bit of a shortcut that always works. To the positive, yep. And then for question I, we have 4 take away 8. And then if you take a look at the bracket after the division sign, it's to the power of 0, which means that the entire thing will eventually become 1. So I didn't even bother to spend time solving it. I know it'll become 1. And so that answer is -4. Did you guys get those as your answers? Yeah, okay, great. Let's keep going. We have a couple more questions to do. Question J. So you know that little trick I just showed you guys? Let's go ahead and use it in this example here. I am going to take the reciprocal of these. It's going to be b over a, and it's going to become to the power of 2. And if you take a look at the power of a quotient rule, you can take the 2 and apply it to the numerator and denominator. So it'll become b squared over a squared. Okay. Yeah, you could still do it the long way. Okay, see question 3. We're finally ready to use that rule that I just showed you guys, that I taught you about before. The shortcut. It's not even a rule, it's a shortcut. What's the purpose of this question? I want no negative exponents because negative exponents are poor form. Now, if I were to do this the long way, I would make b to the power of negative 2, 1 over b squared. I would take the reciprocal, et cetera, et cetera. But I've told you that another way to do it is if you can identify a negative exponent, you can move it to the other location, in this case, from the denominator to the numerator, and you can change the negative exponent to become a positive exponent. Now, if you did it the long way, that's fine. See if you get the same answer as me. I am going to move the b to the power of negative 2 to the numerator, and I'm going to make it b squared. And my a to the power of 3 is already fine. It's where it should be. So it'll just be b squared over a to the power of 3. Some of you who did it the long way, did you get the same answer? You did. So either way is correct. I just find this is a little bit more efficient. But there are rules to this, right? You can only do it when everything is multiplied together. You can't do it when it's addition or subtraction. So it only works in a scenario like this in question L. Yeah. Yeah. If it was like a 5, it would be 5b squared. Yeah. So we can use that little rule again for this example. This is what I'm going to do. I can see that I have a w to the power of negative 4 here. That's going to move to the numerator and become positive. And I can see I have x to the power of negative 2 here. That is going to move to the denominator and it's going to become positive. So when I move everything around, I'm going to end up with 2 times y to the power of 3, because that's not going anywhere, times w to the power of 4, because that's just been moved from the denominator to the numerator, all over 6 times, now my x to the power of negative 2 moves to the denominator, and it's going to become x squared. Is this as simplified as possible? No, because I have a fraction here, right? 2 over 6. So my final answer is going to be, I like to write it in alphabetical order. So w to the power of 4, y to the power of 3, all over 3x squared. Did that little trick help for this, or did it make sense for this? Okay. And again, you can use it here because everything is multiplied together, so you're allowed to use it. Bea? Okay, now these questions can be a little tricky because you're probably like, what exactly are we doing here? We are going to use the power of a power rule in this question, and we're going to multiply the 3 with the 5 minus 6. And the way that's going to look is it's going to be m to the power of 3 times 5 minus x. So you're basically just taking the 3 and multiplying it with the entire binomial. And we can expand that and write it as m to the power of 15 minus 3x. Now, I think this is fine for a final answer. Some people might write it as like m to the power of 15 over m to the power of 3x. You don't have to do this because this isn't technically a negative exponent. So this is fine. You can leave your answer like this. Okay. Question N is very similar. It's going to be 4 times, and I'm just going to separate this so we can see that it's distinct, m to the power of 3 minus x times, and now this is going to be a little trippy because what I'm going to do is I'm going to change the 1 over m to the power of x back into a negative exponent. So I'm going to write that as m to the power of negative x. I do this because now I have the same base m's and I can go ahead and add the exponents together. Is there another way to do this? Yeah, probably. You could have done it a different way where you could have distributed the x to like 1 over x over mx and done it, but this is just one way that I'm going to do it. Now what I can do is I can go ahead and use my exponent rules and I can add the exponents together. So it's going to be m to the power of 3 minus x plus negative x. The reason why I can understand why this question is tricky is because you can probably maybe see 1 or 2 other ways to do it. And if that's the case, go ahead and try it another way and see if you get the same answer. And now we're going to simplify this. It's going to be 4 times m, and this is going to be 3 minus 2x, and that's good for my final answer. Negative x plus negative x is just negative 2x. I ended up using the power laws here. So I have the same base, I can add the exponents together. So I added 3 minus x plus negative x. That make sense? Question O is pretty straightforward. Go ahead and try it yourself. That has no letters, it's just all variables. I mean, all numbers. Why do you have negative x for n in the second step? I don't, what do you mean by n? All I did was I took the 2 m's, like let me just separate this a little bit. So I looked at these two and I noticed that they have the same base. There's a multiplication sign, so I'm adding the exponents together. 3 minus x plus negative x. And that's how I ended up getting 3 minus 2x. For question O, did you guys get 17 over 72? Awesome. 4 more questions to go. So for question P and Q, again, there's no letters. There's nothing really tricky about this, but take a look at question P. Am I allowed to use the power laws for 2 to the power of negative 1 and 2 to the power of negative 2? I cannot. And the reason why is because there's no multiplication sign, right? So what do I have to do? I just have to solve it the old-fashioned long way. There's no trick to this. Am I allowed to move things from numerator to denominator to get rid of the negative signs? I can't do that either. So no shortcuts. You just have to solve it the long way, change everything to a fraction, take reciprocals and solve. And the same for question Q. 4 to the power of negative 1 minus 2 to the power of negative 2. First of all, the bases aren't even the same, but you're not allowed to shift anything around. So what I did was I kept the numerator separate, the denominator separate. I solved, I divided, and those are the answers I got. Go ahead and try it and see if you can get the same thing. For question R and S, I've now given you values for X, Y, and Z, so we're going to end up getting an actual numerical answer. Question R is pretty straightforward. I like to simplify as much as I can before I substitute, but if you didn't want to do that, you'd still get the right answer. So here what I'm going to do is I'm going to start off by taking a power of a power. And negative Z times Y is just going to give me ZY. So my first step here is going to be X to the power of ZY. Sorry, I'm going to write that again. X to the power of ZY. This is probably as simple as it can get. So I'm going to go ahead and substitute the values for X, Y, and Z. So my X is the number 4. My Z is a negative 1. And my Y is a negative 2. So this is super messy. Let's try that again. So this is Z and this is Y. Z is negative 1 and Y is negative 2. Okay, now we can just solve that. So negative 1 times negative 2 is positive 2. and 4 squared is just 16. That one's the easy one. Question S is a little bit more complicated, and I'm going to do it, but if you wanted to try it without me doing it first, you can go ahead and try it and then check your solution. So for this one, I noticed that you can't really simplify much. Like nothing inside this bracket crosses out. Nothing has like a power that can be simplified. And I don't want to take the 3z and substitute it to everything. So I'm going to actually, for this question, go ahead and just start solving. So my x is the number 4. My y is the number 2. And then the exponent here is 2 times z, which is -1. So notice I'm being super organized. I'm making sure everything stays in the exact same position that it was in the question. And I'm making sure I keep brackets around everything because I feel like that really helps. My y is a -2. Z is -1 to the power of x, which is a 4. All to the power of 3 times -1. Okay, looks super confusing and messy, but let's just start solving and see what happens. So we have a 4, can't do anything to that. -2 to the power of 2 times -1, that's just going to be -2 to the power of -2. Then in the denominator, I have -2, -1 to the power of 4, -1 times -1 times -1 times -1. That's just going to give me a whole number 1. Right? So if I wanted, I could -2 times 1, I can just kind of simplify that right away, and I can write that as just a -2. All to the power of -3. Okay, now see how everything in the bracket is multiplied, and I have a -2 to the power of -2? I can go ahead and bring that down to get rid of the negative exponent. Question? How we got in the denominator? So I just solved it. See this part right here, -1 to the power of 4, -1 times -1 times -1 times -1 is just a 1, and 1 times -2 is just -2. There are actually multiple ways you could do this, but I'm going to go ahead and move that to the denominator. So this is the part where people most get confused. So I'm going to do it. I'll take a step back and I'll see if you have any questions. Can you see what I did here? And does it make sense? Does everyone see what happened to the new -2 to the power of -2? Because everything is multiplied together, I just moved it to the denominator. So now I don't have to deal with negative exponents. It's just -2 to the power of 2. Okay, we're going to continue to solve this. 4 over -2 squared is -2 times, well, you can use power laws here and make it -2 to the power of 3. Whatever you do, you'll end up getting a -8 over here, all to the power of -3. Okay, I'm just going to bring this over here. 4 over -8 is the same as -1/2 to the power of -3. To get rid of the -3, I am going to go ahead and take the reciprocal. So I switch the numbers around, and then I can change my -3 to a +3, and that gives me my final answer of just -8. This question can be confusing, but if, like I said, if you just do it in steps, it should make sense here. And made, and yeah, of course, like 1 over -4. Yeah, you could have done that and then solved it that way. You could have also used power laws. Like see how you have a -2 and a negative a 2 at the bottom? You could have used power laws there too and made it -3. Marzu? Yeah. Yeah, sure. So what I do is I'll move it over here. If I have something like a 1/2 to the power of -3, to get rid of the -3, I switch the numbers around, make it 2 over 1, and then I'm allowed to make the exponent a positive. So Yeah, because really the long way of this is 1 over a half to the power of 3, which would be 1 over 8. And then when you take the reciprocal, it'll become 8 anyways. So it's the same thing. Yeah, it's just a little shortcut. Yeah. So you guys, that's it. You don't have any questions, worksheets for this. You will just have textbook questions, but I highly recommend you do them, especially if you feel like your grade 9 and 10 exponent knowledge is a little shaky. So try all of them, page 221, numbers 1 to 18.